Hi, good morning to all. This is Rajshekhar, and in the current day lecture, today we are going to discuss about relational database design. As we all know that the database design is being carried out in various phases, which are requirements analysis, conceptual database design, logical database design, schema refinement, physical database design, and security design. The current topic which we are going to discuss about the relational database design, which comes under the fourth phase, which is schema refinement. As we all know that till logical database design, the database gets ready. The database schemas are ready by the third phase. And what are the works that are going to carry out in the schema refinement? And why do we require this schema refinement? And see that these are all the various topics that we are going to cover in the relational database design. 1. Features of good relational design. 2. Atomic domains and first normal form. 3. Decomposition using functional dependencies. 4. Functional dependency theory. 5. Algorithms for functional dependencies. 6. Decomposition using multi-value dependencies. 7. More normal forms. 8. Database design process. And at the end, modeling temporal data. And when you look at this database design, why do we require this schema refinement? And we have already come across all the three phases till logical database design, and the schemas are already generated. Then why do we require this refinement on the generated schemas? The only one thing which we have to look into that context is, on the generated schema, we could not able to estimate whether the redundancy exists or not. If there exists a redundancy, then definitely we have to follow the schema refinement process. You may be getting a doubt. If there exists redundancy, what happens to the schema? 1. If there is an existence of redundancies in the schema, the dominant problems are 1. Redundant information. 2. Insertion anomalies. 3. Update anomalies. 4. Deletion anomalies. What is this first point of redundant information? Redundant information in the sense we are trying to store the same data again and again at various places, thereby making wastage of space and time, which is very much important when it comes to the processing part. Second one is insertion anomalies. If there is an existence of dependency between the attributes, I'll talk about this dependency between attributes. Let's take up an example of an employee table. Let's assume that we have the two columns. One is rating and other one is salary. Based on the rating, if the salary is fixed, let's say for 8 rating level the salary is 50,000. For 9 rating level the salary is 1 lakh. For the 10 rating level the salary is 2 lakhs. And these are fixed by a company. Mean to say that for every employee must be categorized into these 3 rating levels. Any employee that gets his rating level as 7, his salary or her salary has to be 50k. If his salary is 1k, mean to say that his rating has to be 9. If his rating is 10, definitely his salary has to be 2 lakhs. Mean to say that wherever this rating appears, and meanwhile you have to insert the salary. This means to say that Without inserting one value, you cannot insert the other value. In the sense, without knowing the value of one column, it is not possible to insert the value of the other column. This is what we call it as an insertion anomalous. As with the previous example, we can easily understand that without knowing the rating value, it is not possible to insert the salary value. This relationship can be explained as functional dependency, where rating is functionally determines the salary attribute. In turn, we can also say that salary is dependent on the rating. And when it comes to the third point, update anomalous. As we already know that the association that exists between the rating and the salary values of the employees. At any point of time, a user can able to change or update the correlation that exists between the rating and salary by leaving the database into an inconsistent state. It means that, let's say if we have 100 records related to the rating 7, whose salary has to be 50,000. Now, I'll be writing an update statement which changes 90 records salaries from 50,000 to 75,000 without having the impact on the rest 10 records by throwing the database into inconsistent state, because for the same rating 7, the most of the records are at 75,000. For the same rating, few records are at 50,000. It is not possible as per the company rules. It should not be there. And this is what we call it as an update anomalous. You can able to do that change by throwing the database into an inconsistent state. This is what we call it as an update anomalous. And the last one is delete anomalous. Let's say if I issue a command in order to delete all the employees data where the rating is 7. Where the rating is 8. We have taken 8, 9 and 10 rating levels, right? For the same example, if I'd like to delete all the records where the rating is 8, yes, we can do it. We are going to delete all the records wherever the rating is 8. But you are not just deleting the records which are related to the rating level 8, but in turn you are deleting the association that exists between the rating number 8 and the salary value, which is 50,000. Mean to say that in the delete anomalous, if you delete some information and in turn you have to delete further more information. This is what we call it as a delete anomalous. And these are the major drawbacks of redundancy. And in order to avoid this redundancy, in order to refine the schemas by eliminating this redundancy, and we have to rely on the normalization concept. What is this normalization? Normalization is the process of decomposing the big relations into a smaller relations. While decomposing, we have to remember two important properties of decomposition. What are those properties of decomposition? The two important properties of decomposition are, the one is dependency preservation, second one is lossless join dependency. And I'll be addressing about these two properties later on in this lecture. And first, let's look at the examples about the smaller schemas. Suppose we have started with an instruction department relation. How would we know to split up this instructor and department? And that's what we are talking about. On what basis this normalization, splitting up of a table into pieces, has to be carried out. And it has to be fully relied on the functional dependency that exists among the attributes. Let's look at the second point. To write a rule. If there were a schema, department name, building and budget, then the department name would be a candidate key. Obviously, the department name, it is a candidate or a primary key here. And we can represent this functional dependency. In short, we can call it as an FD. And this FD can be represented as the department name, which determines the building and the budget. Building and budget are the other two columns which are dependent on the department name. And when you look at in the instruction department table, because department name is not a candidate key, the building and budget of a department may have to be repeated. But this is going to be a candidate key in the department table. But this is not going to be a candidate key in the instruction department. This indicates a need to decompose this instructor and department into the instructor as well as into the department. And that's why we have decomposed an instructor or department into instructor as one relation and department as the other relation. Now, not all decompositions are good. Suppose if let's assume that with an example. What happens if we do the wrong decomposition? When you look at this code, employee ID, name, street, city, salary into employee 1 ID, name, employee 2 name, street, city and salary. And the next slide shows how we lose the information. We cannot reconstruct the original employee relation. So this is a lossy decomposition. That's what we are talking about. When you try to decompose any relation, it has to follow two properties. One, dependency preservation. The other one is lossless join decomposition. And see that what is this dependency preservation decomposition? Once if you have identified that there is an FD that exists between the attributes and ensure that the FDs must be preserved. Preserving the FDs in the sense all dependent attributes and the determining attribute should come into one relation. And they cannot be pushed into two different relations, thereby violating the functional dependency. And when it comes to the lossless join decomposition, the decomposition must be a lossless join. Lossless join decomposition in the sense when you have decomposed a relation into two pieces, and those two pieces, if you perform a join operation and you could able to reconstruct the original relation, means to say that when you perform a join operation between the two decomposed relations, you should not lose any information that is there in the original relation. At the same time, you should not get any extra information which is not there in the original relation. And such decompositions are referred as lossless join decomposition. Let's say if you have lost any information which is there in the original relation, when you perform a join operation between the decomposed relation, or when you get an extra information which is not there in the original relation, and this kind of decomposition is referred as a lossy decomposition, which can be viewed in the current example. And see that based on the previous decomposition, if you could able to do ID and name into one relation, name, street, city and salary into the other relation, and based on the name, if I performed a join operation, we have to see the more number of records which were not there in the original relation. This is an example of lossy decomposition.